Tá bom.
Hi, Lynn. This is Mauricio. We are just starting in a few minutes. We will let you know.
Okay, thank you.
There will be a 5 minutes presentation of the seminar. Very quick.
Veja,
We will introduce
já está lá no nosso canal, né? Quando o cara entra. Tá.
Mauricio, you're going to mute my sound, right? I shouldn't do that myself.
Hi, Steve. How's it going? So long.
I'm fine. I just want to know if you will mute my sound during Professor Fu.
No, I think that the general administration, Paulo has it.
Oh, okay. Okay, I just want to know
Your sound is
somebody.
great now.
Okay.
Saudades.
Maurício.
Sim.
Quando quiser, pode começar, hein?
Então, Renato, você que faz a apresentação?
Apresentação, Renato.
Posso começar então, Paulo? Posso tocar o vídeo antes, não?
Não. Pode ir. Já estão no ar.
Bom, boa tarde a todos e a todas que estão nos assistindo. Eu declaro aberto o 18º Seminário Internacional de Nanotecnologia, Sociedade e Meio Ambiente de 2021. Eu sou José Renato e sou da Fundacentro em Santa Catarina e estarei hoje com vocês nesse primeiro dia do Seminanosoma. Nesse seminário serão abordados 3 temas principais: nanotecnologias e agricultura, nanotecnologias e inteligência artificial e nanotecnologias, nova tecnologia e pandemia. Hoje abordaremos nanotecnologia e agricultura. As palestras terão duração aproximada de 20 minutos e faltando 5 minutos eu irei avisar. Após cada palestra, teremos debates com duração de 20 minutos. Agradecemos a presença de todos aqueles que estão nos assistindo ao vivo. E antes de iniciarmos, gostaria de passar alguns informes. Este seminário está sendo gravado e ficará à disposição no canal da NanoWeb TV no YouTube. Os participantes poderão formular perguntas aos palestrantes através do chat no canal do YouTube e as questões serão compiladas no decorrer de cada palestra e respondidas no final durante os debates. Pedimos que os participantes, antes de começar, se inscrevam no canal da NanoWeb TV, deixe o seu joinha e ative o sininho. Assim você será o primeiro a saber quando for postado um novo vídeo. E vamos ao tema da primeira mesa. Public Attitudes to Nanotechnology, Why Application Type is Important. A palestrante Aline Frewer, ela é professora of Food in Society at School of Natural and Environment Science Newcastle University. Please, Liam.
Okay, thank you for the introduction, and thank you very much for inviting me to speak to you today. So the title of my talk is Public Attitudes to Nanotechnology, Why Application Type is Important. A quick overview. I want to consider this from the perspective of food security, to try and understand the importance of consumer risk and benefit perceptions and associated communication strategies. And then I will use nanotechnology in agriculture as a case study. So food security is a real-world problem, and real-world problems are often complex. It's been defined as the situation when all people at all times have physical and economic access to sufficient and safe nutritious food to meet their dietary needs and food preferences for an active and healthy life. It's a wicked problem. It's a wicked problem which is difficult or impossible to solve because of incomplete or contradictory knowledge, because of the large number of people and opinions involved, the large economic burden of getting it wrong, and the interconnectedness nature of the problem with many other problems. Arguably, science and technology will take out the impossible from the discussion. So, how societally acceptable are different solutions to delivering improved security? We've seen a lot of concern about GM animals used for food production. The GM aqua bounty salmon that grows very fast was controversial. It's now licensed in certain parts of the world, certainly not in Europe. Gene editing animals perhaps is less controversial, but it's a topic of current discussion. We have issues, for example, like nutrigenomics, basing someone's diet on their genetic profile, which doesn't seem to have been taken off because people don't really want it. And of course, the subject of this talk, nanotechnology and food production. So very generally, if we consider societal acceptance of emerging technologies in the agri-food sector, the first issue is that there is a need to develop societal trust in the motives of actors involved with developing the products of novel technologies, and to identify the concerns of interested stakeholders, including the general public, and to ensure that these concerns are addressed in the process of risk analysis and regulatory enforcement. We know that there are differences between expert and citizen perceptions of risk. Experts rely on technical risk assessments. They use scientific argumentation, which does not take account of socioeconomic impacts, but rather, if you like, biological impacts, impacts on human health, impacts on the environment. In theory, in regulation, in discussion, it should be possible to balance risk against the benefits, but it's not always clear how socioeconomic benefits or even technical benefits are assessed in the process of risk analysis. The public use their risk perceptions to make judgments about risk. They require risk communication to take account of their concerns, as well as technical risk estimates. And emotional or affective responses are important. And this is particularly true in the agri-food area, where some people are neophobic. They view new developments, new innovations in a very negative way that can arouse an affective response. And this is how people tend to think of the countryside, as a sort of bucolic ideal. they look on it fondly, and they have expectations about the sorts of ecosystem services that the contemporary countryside will deliver, whereas the reality is much more like this. So, distrust in science and its institutions. This potentially occurred after the publication of The Silent Spring in 1963. We know now that many pesticides, particularly those initially developed, have negative ecological effects, that their injudicious use leads to pesticide resistance. But people will say that scientists told society pesticides were safe, and they weren't. The consequence was diminished trust in institutions, regulatory processes, and science itself. So potential human toxicity has been identified decades later, including residues on food. There are major health impacts on farm workers. This has highlighted the introduction of agricultural technologies with uncertain health effects, short-term gains, and potentially promoting the interests of powerful stakeholders. People perceive the risks as being unnatural. They perceive that alternatives are available, that these risks, exposure to the risks, are unnecessary, that the risks are out of control, and negative risk perceptions, once established, are difficult to change, even with new regulations and evidence. What does this mean for novel and potentially beneficial emerging technologies, for example, nanotechnology? If we go back to 1998 and see the very visual protests against genetically modified foods that resulted from the unsegregated introduction of genetically modified soya into Europe. And these images are pulled off the internet, but they're not shared on social media because there was no social media in 1998. The results of a meta-analysis, actually quite old now, from 2013, surveyed the enormous number of publications looking at attitudes to GM. And the conclusions were that actually most data have been published in North America, Europe, or Asia, that plant-related or general applications were more acceptable than animal-related applications. Pharmaceutical production was more acceptable than food-related applications, and that risk perceptions were greater in Europe than North America and Asia. Benefit perceptions were greater in North America and Asia than Europe, and moral concerns were higher in North America and Asia compared to Europe. It's quite an interesting contrast there. Risk and benefit perceptions increase with time anywhere. But what this is beginning to show was it's not the technology that people are concerned about, it's what you do with it. That food-related applications are less acceptable than pharmaceutical ones, and that animals are more controversial in the context of GM than plants. So we might predict from this that consumers will reject the products of nanotechnology applied to agriculture. This research presented here looks at what nanotechnology experts thought the public would think. What I will point out is that there has been some protest against nanotechnology, but it's been very, very limited compared to the kind of controversy that was associated with GM foods. So what we found was that most experts thought the public would reject nanotechnology applied to food production. Some of the questions that arise from the set of interviews that were done with experts are: do the applications to the agri-food sector meet a recognized societal need? Can we identify similarities with potentially societally controversial aspects of other agri-food technologies such as GM? Are there additional issues raised over and above those associated with other enabling technologies applied to food production? And what needs to be done to fine-tune the development and implementation of agri-food applications of, for example, synthetic biology, which is the new technology being applied in this space, to align with consumer priorities and the adoption and commercialization of specific applications. So let's go back to those expert interviews. And what we got them to do was rate each of these applications of nanotechnologies in terms of how acceptable they thought the public would find them. So it's not acceptability to them, it's what they thought the public would think. And I've kind of shaded those applications related to food production. Here's the results. They were fairly, the closer the application is to the dimension here, this is the results of a generalized precocities analysis, the more the experts thought the public would be concerned that the applications would be misused, abused, and the issue of whether benefits accrue to producer or public would become important. So that includes encapsulation, delivery of nutrients in food, for example, in relation to nutrition precision, smart pesticides, food packaging. In contrast, no concern necessary and useful, these more medically related applications, such as targeted drug delivery and neuroimplantable devices. Risk was associated with smart dust, RIFID tags, and benefits. They didn't really think the public would see that many benefits associated with any of the applications. So coming back to the civic protest, has it made any difference? Let's consider what the public actually think. We conducted the same exercise with the public, asked them the same questions as we asked the experts. What we actually found here was, to be honest, the public in general didn't see food-related applications, or indeed any applications at all, as being particularly controversial. There were concerns that there might be alternatives available, for example, in relation to sports goods, that smart pesticides or smart dust for military use were not needed, but those food-related applications were actually linked with importance and the perception that actually these could be quite useful and beneficial. So, has nanotechnology being applied to food production resulted in public concern? Despite those images I showed earlier, there's not been extensive consumer protest or rejection of nanotechnology applied to food production. At present, there are no legal requirements for labeling, but it's quite difficult to define what a nanoparticle is. Sometimes it's defined as a particle between 1 and 100 nanometers in diameter. Sometimes it's used to define larger particles, or those that are less than 100 nanometers in only 2 directions. And of course, nanoparticles occur in nature. So how do you regulate for those in food production. Here, we've considered some of the ethical issues which can be used as a tool for identifying and discussing the ethical aspects of food production. It's assumed that food production developing interventions has an impact on the organism used for food production, the producer, the manufacturer or farmer, the consumer, and the biota, other living things in the environment. For each of the above, the ethical matrix is used to assess the impact on them in terms of autonomy, dignity and identity, beneficence, to do good, non-malfeasance, to do no harm, and justice, which is fairness. We can produce an ethical matrix and perhaps identify some potential ethical problems. But, sorry, I'll come back to that. We know, for example, that the use of technology might result in disadvantage to some groups within the population. For example, farmers living in less affluent countries. With nanoscale genetics, there is a potential for negative consumer attitudes, and that would follow on from the GM debate. But to be honest, we simply haven't seen that happen. And I guess in terms of uncertainty, unintended effects, population level variability in terms of responses hasn't been observed in terms of the development of risk. There was a debate about nanoparticles bioaccumulating in neural tissue, and I think the only real evidence they found of an effect has been in relation to cardiac tissue. So I realize I'm almost out of time. Some conclusions. Societal acceptance or rejection of emerging agri-food technologies is dependent on time and context. At the moment, we're looking at synthetic biology, and the aim of this research was to perhaps consider learnings from GM and from nanotechnology about acceptance. And to be honest, we're again seeing a public that want applications that have concrete benefits, where those benefits are shared by society. There may be learnings from consumer responses to one technology, but rejection of one type of technology or one application would not automatically lead to rejection of another. Everything needs to be considered in the context, in time, and what that application delivers. So I would argue as a final point that stakeholder involvement and co-production of different applications is the key to developing products that consumers, that society, that stakeholders want and need. And I'll finish there. Thank you for your attention.
Thank you very much, Professor Fruer. You can, then we have your image. It's a pleasure, and thank you very much. I will make some comments, and then there will be a few minutes for questions from the audience. We have also streaming on YouTube, so there might be questions on the YouTube channel as well. Well, first, Professor Fruer, I would like to thank you very much for your interesting presentation. And I will say, just as a compliment to your talk, that as we know in the audience, and the specific topic of this session is about nano in agriculture, and there have been a lot of developments for food-based organic nanostructures derived from carbohydrates, lipids, and proteins such as nanoparticles, nanotubes, nanoemulsions, nanocapsules, another inorganic nanoparticles such as titanium oxide, zinc oxide, silicon dioxide, etc., carbon nanotubes at various nanoscale components produced through different paths and used for different purposes in the food industry, as you comment in some examples in your presentations. So there are a lot of innovative food products
Tá me
manufactured.
ouvindo, Paulo?
Sorry?
Tá me ouvindo?
Uh,
Não, eu já entrei.
Okay, sorry for the interruption. So I was saying that there are this application of nanotechnology in innovative food products with the promise of many benefits for consumers and industry as well. However, these nanomaterials ranging from organic to inorganic components might introduce some uncertainties. That is one of the issues that Professor Fruer put into this discussion, and unforeseen impacts when they might be used not in an adequate way in agri-food materials. So there are potential risks to human health and environment through high levels of exposure, ingestion of food that has nanoparticles, for instance. So these potential risks and toxicity issues due to ingestions of these fine nanoparticles leads to concerns, and these concerns should be clarified and or eliminated. But one thing that I want to put into value from Professor Fruer presentations is the frame for the discussions of these issues. And the question that is to be asked, as Professor Fruer says, do the applications of the agri-food sector meet a recognized societal need? Excuse me for my English. What is the recognized societal need, and how is defined in what frameworks when we talk about not just a perception of risks only of consumers, but taking this as a process of social definition of risks and the societal needs of new technological innovations. So that's one thing that it's very important. What are the questions to be asked? So we are talking about the frame for the discussions of these developments. What are the risks involved, and who is going to pay for that risk? Or as Ulrich Beck said, we are a society of risk. We are the risk society. So we should assume what level of risk we are going to be ready to accept or not. So in that sense, it's also important to learn from the lessons from GM and the massive use of pesticides. You know, Professor Fruer, that Argentina and Brazil, we are major consumers of agrochemicals. So our countries have a lot of very high impacts, health impacts, environmental impacts of the massive use. So that lessons we are very aware of. And that comes very interesting with the point that you propose to think about what is the question to be asked. And one second thing following this question to be asked, what are the needs? What are the consumer priorities? There is another related issue that how does these issues become a public concern? Because, as you say, there has not been an extensive consumer protest or rejection of nanotechnology as it was like the GMs, for instance. And we can see this in other areas, not just the consumer concerns. Also, when we talk about regulation, for instance, there is very little developments in nano-specific regulations compared to what is regulation in biotechnology. I think that this is another issue to discuss, and it's very interesting. Not only if nanotechnology in food is a public concern, but also how is the public concern built in a very general public that includes not only consumers, but also legislators, regulators, industry, etc. Many organizations also of the civil society concerned about these products and the potential impacts. So that will be another question that I think that is very interesting from your presentations, among different things. And I will say one more just to allow other questions and debate. But they think about the differences between expert and citizen perceptions of risks. And it seems that on the side of the experts, they will be much more rely on technical risk assessments than the public, that mostly the risk perceptions come from, well, I don't remember now the name of the author, but he talked about the intuitive toxicology, which means not informed by science. But regarding this point, I would like to say that it's not only this difference between how experts construct their perception of risk and how public construct their perception of risk, but also another issues that are involved in this construction of the perception of risk, such as the production of confusion or ignorance, where there are many responsibilities, not only from the science sector, but also from industry. You know that you talk in your example about Monsanto, and we knew about the trials, the Monsanto trials in California, that there was a lot of manipulation of the information regarding the evidence. So how the evidence is produced, there is a problem, and it should be incorporated in these relations or tensions between experts and public in the construction of the perception of risk. I will say that for now, I hope I was some clear. Sorry for my English, Professor Fruer, but I just wanted to make these points, like highlights of your presentation, that I found really interesting for the debate that is opening our session on nano and agriculture. And now I would like to open for some questions of the other participants of the panel and also from the public.
We can see the answer from Lynn, and after this, maybe another questions.
So, Professor Lin, if you can, you would like to add, if you could understood my English?
Yes, no, your English is perfect, and I'm sorry I'm not doing this in Spanish.
No, please.
I feel very ashamed. I think there's still a view prevalent among experts that the public are in some way irrational, and that they want to apply a deficit model, give people information, scientific understanding, which will result in them accepting technical risk assessments. And we've seen this with nanotechnology in agriculture and beyond. We're also seeing this with synthetic biology applied in agri-food and also in other contexts. And in fact, the public are not accepting these technologies because they don't understand them. It's driven by, if you like, a plurality of other values which are informing their decisions. And I really think with nanotechnology, there's a whole issue of why are we applying it? Is it useful? Does it benefit people? Does it benefit society? and to whom do the profits of its exploitation accrue? Because any risk, even if it's really small, which accrues to society or environment, the environment more generally, I think might be negatively received. I see Steve has his hand up.
Yes. So I think one of the issues that have not been surveyed are attitudes among workers, because it's workers, both industrial and agricultural, who are most chronically exposed to nanomaterials. During the first phase of nanotechnology, there was just an attempt to try to figure out which of the nanomaterials had pretty much inherently high hazard. And those were nanometal oxides and nanometals. And some of the early applications and the risk science done about them showed that these nanomaterials were bioaccumulative in organs that the nanotechnologists had never imagined would be exposed to nanomaterials, that they would go from the lungs to the liver, to the pancreas, and so on and so forth. So I think that that's an issue both for industrial applications of nanotechnology as well as agricultural applications. And I just haven't seen that kind of survey of workers working with nanomaterials in industrial or agricultural settings.
I think that's a really good point. I haven't seen them either. So perhaps that's a gap in the literature. Fatima, am I supposed to be picking up the...
Yes.
Go.
Hi, Professor Frewer. It's a very pleasure to talk to you, and congrats with your presentation. I have a very quick question, and about the preoccupation of the outcomes. I'm a physician and I'm a doctor, so I would like to ask you if you think that in the future, in regard of the outcomes, it will be necessary to carry out some RCTs in a prospective study in comparison with the consumers or in controlled ones. With this everything about the nanotechnology in food and agriculture and everything, do you think it will be possible and necessary, like a randomized controlled trials?
I think it'd be quite difficult, mostly because there are so many nanoparticles occurring naturally, as well as the manufactured ones.
Yeah. Out.
I suspect it'd be very difficult to do. But if you can present to me some really good arguments to convince me that would be a good idea to do some randomized control trials, then I will listen to your opinion on that one.
Okay, I'll try. I'll think about it. Thank you very much.
I think Steve wants to.
There is quite a bit of screening and databases now on the different characteristics between naturally occurring nanoparticles and engineered nanoparticles. There's a whole project in the European Union called NanoSafe, which is supposed to develop a kind of hierarchy of safety among nanomaterials and specific uses. And I think the acceptance of nanomedical applications, including, well, at least partial acceptance of nano-enabled COVID-19 vaccine is because it's not a chronic exposure. Whereas, if you are spraying a nano-enabled pesticide every day, or if you're manufacturing one, or if you're manufacturing a nano-enabled fertilizer, then you have a different kind of exposure, and you have much less protection. In fact, at least in my contacts with U.S. officials, they have no current plans to develop personal protective equipment for farm workers that would enable the filtration of the nanomaterials that are being considered for use in nanotechnology applications. I think, and I don't think that that's because they don't know about the risks. It's just that COVID-19 has overwhelmed their research capacity and their budgets. So.
I mean, that could well be true. Just referring to the data on public perceptions and attitudes, I would say that if people, rather than regulators, are making decisions about the acceptability of different applications, they are making a risk-benefit trade-off, but in terms of how they value those risks and benefits. So on one hand, of course, we must look at the protection of workers from nanopesticides and so on, but that would not equate necessarily to public acceptance of those pesticides, because very generally, people don't like pesticides at all. So, my intuition is that no matter how much you protect those workers, there will still be one of the applications that's quite low on the priority list for adoption in society. Whereas pharmaceutical applications, where there's a potentially a risk, but there's also a huge benefit to the person involved in that application. That's the way that's perceived by society more generally, is always going to be seen in a much more positive way. And I know we've seen some interesting responses to COVID vaccination, but by and large, that seems to be the kind of response we're getting from most members of the public. If that makes sense. So it's really about why are we doing it? Are there alternatives available? Do the perceived risks outweigh the perceived benefits? And I can see Fatima's got her hand up.
Just a few comments, especially in Brazil. We ask how much do people know about it, exactly about it, and especially COVID-19 vaccine that there will be a presentation this event, RNA and everything. I guess here in Brazil, we are trying to inform the maximum we can, but I think there's still a work in progress, I guess.
I may add, the other issue to think about is how the social media is being used, because we have a confirmation bias, and that we select information which constantly reinforces what we already believe. And even more so, we're targeted with information which, if you like, technology platforms, the AI systems, think we want to believe, because that's how you sell advertising space. So, it's quite a formidable context in which we're living in terms of, I suppose, creating an informed debate. I would put that up for discussion.
Professor Fleur, we are getting to our time for the next presentation, but I would like to ask one last question, if possible. It's been very interesting, and our seminars They have a lot of debate also. We are very engaged with these issues. I was wondering if your work, even though you are not working anymore in nanotechnology or related, because you are much now involved to synthetic biology. But I was wondering if this kind of research that you conduct at your university has a correlation with institutional, from the government, activities of public audiences regarding the liberation of and commercialization of these products. How is the situation in the UK now with the release of these products? Do they have any public audience or consultancy? I don't know if I was clear with the question.
Yeah, thank you for that question. With nanotechnology, I don't think it's a huge priority. But in terms of funding, either through the Horizon Europe program or our local funding agencies, then they're very insistent on taking a responsible innovation approach, which means at the outset, you discuss with stakeholders, with members of the public, with consumers as opposed to citizens, but also citizens, about what they want to see coming out of the technological innovation process. And this is not a bolt-on at the end of the project. It really does mean true co-production, co-development. So that could be in a living lab, it could be in setting research objectives, it could be looking at impact pathways, or all of those things. But it really is becoming a condition of funding.
Thank you very much, Professor Fruer. It's been a pleasure to have you in our seminar, and you are very welcome to attend the other sessions, even though there's another time difference in the UK, so feel free. Renato, você quer continuar com a apresentação?
Não,
Eu quero, Steven.
não, daí agora a gente tem que esperar o Paulo ativar o link no YouTube para a apresentação do Steve. Daí eu já chamo o Steve. O Paulo já vai me avisar aqui quando estiver pronto.